Alrighty. See, we are having quite a full attendance. Welcome everyone to Teraflow's very first Ask Me Anything. But please don't ask me anything. I'm just the face. The purpose of these sessions are twofold. Firstly, it's really an opportunity for you to get to know the guys making AI work for our clients, while answering those burning questions that you haven't managed to find the answers to on Stack Overflow. I'm your host with the most, Simon Katende, sales engineer at Teraflow. Before I pass the baton to these starlights, I just wanted to share with you what came to mind when I heard the term feature store for the first time. I kid you not, I pictured a Chili's Woolies store with beautifully packaged features. I know my brain is weird like that. But jokes aside, I think what's quite exciting is that as an industry, especially in the South African or even the global space, we've reached a maturity in machine learning where it's not accessible, or it's not acceptable to hack your way through a machine learning model just by getting sample data from somewhere, running a Jupyter notebook, and then expecting to push those models into prod without thinking of reproducibility and collaboration. Just a few thoughts I thought about with this topic. So here are some of the house rules. So it's an AMA, Ask Me Anything. So really it's a free form webinar where you, the audience, get a chance to pick these geniuses' brains. So I'm expecting at least 38 questions. And if I don't get those questions, boy, I'm going to start randomly asking questions. So I hope you came prepared, Bradley. Now that's all done, I'd like to introduce. Sorry?
I've got all the notes written down here.
You got them? Okay, I'm excited to hear that. Now that's all done. I really love to introduce the heavyweights of the ML space in Teraflow. So the first person I'd like to introduce is really the embodiment of this millennial lifestyle, remote living. Joburg boy that had enough with the hustle and bustle of the Joburg life and moved to a really small town, coastal town called Simonstown. And when he's not solving problems in machine learning and data engineering, he's literally Aquaman. I kid you not, he literally holds his breath and goes down at least 15 meters to go see his sea buddies. A true polymath. I mean, this guy was a high school jock and all-rounder, a film school dropout. I mean, claiming that it wasn't stimulating enough. Then he went on to pursue studies in human physiology, went and did honors in that, and then pursued masters in data science, and frequently shares his views in the ML community via platforms like Biz Community. So please, ladies and gentlemen, can you virtually give a round of applause for Christian Viljoen? Now, the second wizard I'll be introducing is nicknamed after the supervillain Marvel character, Dr. Doom. Truth be told, it's a nickname that I coined, and I'm hoping that it sticks after this, but I'm not really keeping my hopes up. Now, this guy is a PhD, a pretty huge doctorate in machine learning. But don't get befooled. When this guy is not handling ones and zeros, he knows how to do hand-to-hand combat and knows how to handle a rifle, being in the Austrian army for some time. And when he's not in his desk, he tends to de-stress by really switching from the digital world into the analog world, and really focuses on getting his hands dirty in refurbishing classics. One of the ones he's proud of is the 73 Ford Escort. So please, guys, can you raise your hands, not even raise your hands, but please give a round of applause to Dominic Kafka. Yeah, we can't really see that, but yeah, it's always nice to think that it's actually happening. But yeah, now the floor is really up to the geniuses of Teraflow. So wizards, please, can you have the platform and really just set the scene for the importance of feature stores?
Cool, thanks, Simon. Now that you've butted me up for that, all I can do is say thanks to the marketing team and fail on expectations. We'll have some fun doing that. Anyway, so thanks everyone for being here. Thanks, friends, and colleagues, and future colleagues, perhaps, who knows. Yeah, so I suppose we're talking about a problem to solve. So what is the ein Problem architecture? Mainly the issue would be decentralization, or just chaos, really. The main focus of a feature store is really centralization, right? You want to get features some way. Okay, why features? All right, so here we have a little bit of an architecture, something that we've seen a couple of times. Multiple data sources. Obviously, we don't have to go into the big data problem, but there's data all over the place. We want to get it together. We want to string it together. We want to make it useful. And in between, you might have transformation processes. Partially, you might be using transformation processes just for analytics, or obviously, eventually, you might want to get down to some AI modeling. So you might have transformation processes for those. Generally, so I mean, there are two ways to go about this. You could have a top-down approach or a bottom-up approach. The top-down approach would be you start off with a model that you'd like to build, maybe like the chaps at Criterion, aka Bradley. How's it? You might start with an ML problem that you then want to feed data into, or typically in your larger enterprises, what you might have is the bottom-up approach, where you have your data, you stringing your data together. You want to visualize the data, understand the data, and then you might say, well, what can I do with this data and how can I make predictions with it? So that would be the bottom-up approach. In both cases, you've got transformations that occur before you get to either analytics and viewing the data and understanding it visually, or to your ML model. So often, these would be one and the same, particularly if you're going from analytics to the model. So you're promoting from analytics, you've understood your data, you know more or less what it's about. You obviously would understand your business the best, or the process that you're trying to map the best. You've understood that, you know what you want to promote or what you want to predict, and then you want to now do the ML model with that. So you might be sharing, and this is the main point, very often you'd be sharing transformation processes between different pipelines. And this, as soon as this occurs, this is the place where you want to start thinking about a feature store. So if you're not doing this, what might this look like? Well, it's slow in dev time. You're spending a lot of time doing development. You're redeveloping things that have been done over and over again. This obviously scales badly, not only from a technological point of view, so high cloud spend bills, that kind of thing, but also just in terms of projects and dev time. Obviously, this would then also be disorientating to anyone who wants to work with the pipelines or was working between the pipelines, the various ones. And obviously, due to there being higher degrees of freedom than they need to be in the whole system, there's the potential for higher error. Thanks, Brett. Can we move on to the next one? So then the obvious solution would be, well, you want to centralize the transformations. So the core idea really of the feature store, or of any feature store, is taking transformations from these disparate locations, various pipelines, various business entities perhaps, and then bringing them together to create one or couple of feature stores. You could have numerous ones in line. We'll get to that shortly. So obviously this would then slow down speed up, dev time, because now you're not doing it in various different places. You've got it in one place. Hopefully you also have some documentation or a central repository where you can find out what exactly all of these features are and navigate through them. So that would then scale better, not only from a technological point of view now, because the processes are not duplicated all over the place, but also from a dev time perspective, you can get to the problem and only develop new features as you require them, and you know where the old ones are, or the ones that you would like to use. And of course, you can then work on standardizations. What comes with that too is also better governance. You know where everything is. You don't have perhaps 3 versions of the same mean or other whatever statistical entity you're trying to calculate out there, and now knowing, are they all the same? You know exactly. If I'm calculating the mean, for example, this is where it is, and it only has one shape or form. And then obviously, because there are less degrees of freedom, less risk, and less potential to mess things up. So I think, yeah, let's move on to the next one, please, Brett. So then there's also the version of, well, do I just need one feature store? Or can I think of a couple? Or what are my options with this centralization idea? So you could then centralize for various things, for various functionalities. On the one hand, obviously, considering the bottom-up approach, you have a feature store that could be dedicated, for example, just to analytics. So you start off with like transformation, stuff like averages, means, aggregations of various kinds, groupings, clustering, that kind of thing. And then you could visualize those. Visualize them, you understand your business process better, you're discovering trends, you're discovering things about your data. So kind of the bottom-up big data approach. Then thereafter, you might say, okay, that's cute, but I need to really do some very crazy transformations for the ML model such that it can do what it needs to do. Okay, so I might have a secondary feature store that has more transformations in it that are potentially more complex. They might be, say, more abstracted. You might use, I don't know, principal component analyses, for example, or you might explode your features out. So starting with something that was aggregated and break it out into various things. So more of an exploratory kind of approach. So point being, you can then break up features. You don't have to just have one central repository for all of it. You could have feature stores that are broken up and also have cross-pollination between them. So at the bottom, for example, there's the arrow that says, well, you might have a model that uses some of the more, say, crazy features, or it just uses some of the more simple ones as well, because you could do, say, sensitivity analyses on the features and find out, well, which ones are really useful for my model. And I think for me, I will pass on to Christian.
Thanks. Brett, you can just stay on that side for a second. I just wanted to add to this. So if you look at that first feature store there in the purple, you can almost think of that as your humanly interpretable feature store of reusable features for various models and teams. But what you can then, if you see the ML feature store afterwards, there are some tools, for instance, Python's feature tools library, which does automated feature generation, feature engineering for you, and it runs a whole array of pre-computed, pre-defined ways of generating new features, which can sit in that next layer there. And then, of course, you can also have features that are very specific to a model, which builds upon the base features in that purple feature store, but has some very custom transformations that aren't really reusable across the enterprise. And in that case, they don't necessarily have to sit in that feature store. Can maybe go to the next slide, please. All right, so there are various ways of implementing a feature store. In theory, you could build a feature store in a SQL database. You could build it on AWS, you could build it on GCP or Azure. You could build it on your on-premise architecture using custom tools. But they all have certain things in common. They all need to be able to ingest data, whether that be streaming or batch data. They all need a means of transforming that data into features that are useful for machine learning. They need a storage layer to persist those features for other people to consume them. And then obviously a serving mechanism towards the model, whether that be a notebook or to an API. Then they have to have a registry. So people need to know what features exist and perhaps in some way understand how those features were calculated. And then you can see at the bottom there, you have your data scientists who can use that registry to see which features are available. And if the feature that they need is not available, they can add it to the registry and do so via the transformation pipeline that exists, so that all of the transformation logic and the registry is in one place. And then the data scientists can then make use of those features in the model training, deployment, and all that. So in the next slide, I'm just going to show you how that might look on AWS. And then after that, I'll show you how that might look on GCP. So in AWS, you'll use Kinesis Firehose or Kinesis Data Analytics to ingest and stream your data into various data sources. You then have a storage layer, so a source storage layer, for instance, in your batch data, which can be either an Amazon RDS instance, a Redshift cluster, various S3 buckets, and that data can then go through the transformation layer, which generally can be done in something like Glue. You could either also do it in EMR. Then you can also use make use of SageMaker's Data Wrangler. For the registry component, generally we would use AWS Glue Data Catalog, which would just go and crawl that data sitting in S3 or wherever it is. And then you have an alternative to that, which is the SageMaker feature store. And then you have the eventual storage of your feature store, which can be S3, or alternatively, it could also be a database. And then you have monitoring components in your CloudWatch and DynamoDB, in which you can capture metadata, and you can then also visualize the health of your feature store using something like QuickSight. You can serve your features to endpoints via SageMaker endpoints or Amazon API Gateway. And then you can also do batch predictions using SageMaker internally. So this is sort of an AWS version. On the next slide, you will see the GCP version of that. I did see that there were some questions in the chat. We will address those.
Christian, just for Graham's question. So I think it's important we take that step back and really ask ourselves, what is a feature? Can you please answer that question for the audience?
Sure. Okay, so a machine learning model generally, like it needs data, right? So it's a mathematical function that's been trained to make a decision based on some input information. So if we did something very simple, like for instance, you could almost predict a person's body mass index, which is your BMI, based on two parameters, which is your height and your weight. And there's a very defined formula. It's your weight squared, or your weight divided by your height squared, right? And that is your BMI. So that's like, there's no two ways about it. That is your BMI, right? You could actually train a machine learning model to predict that using those two inputs, so your weight and your height. Those are the features that the model uses to make its prediction. If you think of it in a more, something you might see in your day-to-day business, if you think about sales forecasting, you could say, what was my sales in the last 3 weeks, or the last 6 weeks, or the last 9 weeks? What is my current stock levels? Some historical information about what happens at a certain time of year. Those can all be features to predict what my sales might be on a certain day. So what we're calculating in a feature store is we're going from base data that might be sitting in your point of sale system, or in your in your ERP system, and we're transforming that data into a way that it's useful for a machine learning model. And quite often you can almost, as a data scientist, look at the data you've got available and think, would this be a useful thing to predict something else, right? So if I wanted to predict how long it might take to deliver goods to a certain store, I might want to know about the traffic volume. I might want to know about the time of day. I might want to know about these things if I myself had to make that decision. But then we actually give that information to a machine learning model, and it finds a mathematical description of how those things are related to the outcome you want to predict. I hope that answers the question.
Graham, are you happy with that response?
That's great. Thank you very much, Christian. Can you hear me?
Yes, thank you.
Just a follow-up question then. If I had an analytics system that already tracks a number of KPIs, for example, based on various business objectives that we're trying to achieve, could I use those KPIs as features, essentially?
Yes, definitely. If they are related to the outcome. I don't know in which field you're operating. If you could maybe give me an indication of that. I could
So we do a lot of work in the industrial information management sector, production, utilities, renewables, that kind of stuff. So kind of heavy engineering stuff. And a lot of our data is time series data. Mm-hmm. But we distill that down to effectively PIs and KPIs. Mm-hmm. So we've got the element of time, but we've also got this kind of vertical of hundreds of different KPIs that we are always tracking.
Look, I think that's definitely the fact that there are KPIs mean they're important metrics to your business, right? And I think you could maybe even find that you can use some KPIs to predict other KPIs. And especially since it is a time series based thing, you can almost find that when one thing goes down, one thing goes up. So I definitely think that that is something you could use in training machine learning models, and you could perhaps find some external thing that could be predicted using those KPIs. Just increase in, if I'm thinking about something like a retail company, like how many extra stores do I have? by default, my revenue is going to be higher because I just have more stores. And that's a very simple way of thinking about it. But all of these KPIs kind of relate to one another. As this goes up, that goes down, and you can kind of find a state where each thing is predictive of the other.
Yeah. Okay, great. Thank you, Christian.
And I think maybe just to add on to what Graham was asking, I think, I see that Dominic, you actually have your hand up. So please feel free to jump in.
No, I just wanted to add on one little thing. So yes, those KPIs could be perfect features. And I think a good example would be, so you're tracking those KPIs already. You've calculated them already. You don't want to have to recalculate them when you do want to do a prediction in the kind of model that Christian's describing. So you'd want to, a feature store here would be a good use case, because one would say, okay, for me to track them, I need to calculate that KPI in any case. Great. Once it is calculated, I want to then put it straight into the ML model. I don't want to have to recalculate it and introduce the potential for error there.
That's a good point.
Yeah, absolutely. That makes sense. Thanks, Dominic.
I think maybe just a question just to substantiate on what Graham was asking is that, is feature stores only for machine learning models, or can one still use it for analytics?
You could use it for both. I think in general, people would also be able to get away with a data warehouse for analytics, but quite often you want to cross-pollinate, and sometimes you'll find that the data that you're creating very customized for a machine learning model can also be a useful analytical feature to track on a dashboard somewhere. Dom, I don't know if you have additional thoughts there.
Yeah, no, it's exactly right. It's in some ways, feature stores can be, just disguised as a data warehouse to some degree, or operational data store. Obviously, feature stores became more popular in terminology for specifically for ML. But ultimately, it's if you have repeating transformations, centralize them. That's really the idea.
I agree. And I think quite often in companies, you'll find that there are, like Graham was mentioning KPIs, there are various different business units that are tracking a similar metric. For instance, how many customers do we have? And if a different business unit is calculating that in a different way, that can wreak havoc in your reporting, and might just be that one business unit forgot to discount the people that aren't customers anymore, and the other one wrote a query where we're still counting those people. So a feature store could be a nice place to kind of be, this is the source of truth about our business. Like, this is where we define those features, and this is the only place we do that. And also, not everyone has to go and calculate that number, because we've calculated it for you. You can just go and consume it. You don't need to write your own query to get that.
Yeah. One example on this, sorry, just to add to that, one example of this that I quite like is, okay, you want to get an idea of an average, right? Okay, great. What kind of average? Are you going to take the median as an example? Do you like modes? Are you going to go with the standard mean? Are you, given that you're going to go with the standard mean, are you doing exponentially decaying means? Are you doing averages over windows? What does that look like? So just going from a concept of, I would like to know more or less an average of some metric, immediately you can have numerous mathematical implementations thereof. This is obviously also a great place where you'd want to have a feature store. This is how we're calculating the mean. This is how we're going to do it. This is why why it's reasonable for our business process to measure it in this particular way. And here you go. If you're going to do another version thereof, awesome. Call it something else, but just make sure that you're distinguishing between the two.
Definitely. I think, and there are some tools that help you with this. For instance, something like Calibra, which has a data catalog, but which each feature almost has an explanation of what does this actually really calculate and how is this calculated. It also has data lineage, so it tells you which data sources were used to calculate that. And if there was a mistake in one of those upstream systems, that's auditable, and you can actually go back and find in your history where that mistake was made. And then similarly, it also allows for, let's say, data access across various different silos and bringing all of that together into your feature store. So there are some tools that also help you do this.
Okay, no, continue. I was just gonna add on to that, but
yeah, go for it. I was just going to go to the next slide, but yeah, if you've got a point, we can talk about it.
No, continue. I'll ask my question afterwards. And Bradley, I'm looking forward to your question as well.
Perfect. So here we just see the GCP version of that. So we've got Cloud Data Flow for our streaming data and for our transformations. The batch data can sit in Cloud SQL, in BigQuery, or in cloud storage, or elsewhere in your on-premise systems where you could do some custom ETL processes. For your transformations, you could also make use of Cloud Data Proc, which is more of a Hadoop-based infrastructure, where Cloud Data Flow is more of the new Beam, streaming kind of way of doing things. Your monitoring and logging can sit on top of your monitoring layer. And then we also have the option now with Vertex AI of having TensorBoard for monitoring. So I quite like the way the GCP incorporates a lot of the TensorFlow, TFX, TensorFlow Extended into their way of doing things. So there you've got the monitoring, then you've got the storage in cloud storage or in BigQuery, which, by the way, you can actually also run machine learning models inside BigQuery now, directly on the data in there. You've got serving using something like Cloud Memory Store if you need a very live data source. And then you've got your registry in Cloud Data Catalog or in Vertex AI's implementation of Feature Store. And then again, you've got your data scientist sitting in a notebook if he wishes to do that, and most people do. And the deployment can then happen via Vertex AI's prediction servers or cloud APIs. That's about it in a nutshell from the cloud services that you could use. But the point that I really want to try and make here is that it's not so much about the technology that you use, but it's more about what do you need in order to have a feature store, right? You need data sources, you need a way of transforming those into something that's useful for machine learning in a central place that everyone knows that this is where I get my data for machine learning. And if the data is not there, I have a way of adding data to that. And quite often that what you need then is you need someone to provide this environment to your data engineers or your machine learning engineers. So there's two aspects to it. It's the environment for the feature store, and then there's the development of the feature store. So some people need to think about what mathematical logic do I need to implement to create these features, but someone else needs to think about the tech stack behind that. Is it being monitored? Is it being logged? Is it what happens when the job fails halfway through and I need to roll back because I wrote some data that's sitting there, and if I run the job again, I'm going to have duplicate data. So there's various concerns in this kind of space.
So Christian, I just want to ask a question, just tying to those components of the feature store. I mean, obviously not every organization is going to be able to do a fully fledged feature store. So like, what are the bare minimums that one requires to have what is called the feature store?
I think I spoke to Dom about this the other day, and we were kind of saying that all you really need is an ETL tool with source data, and you need a storage layer to save that data, and then you need some form of catalog of that data. Right. So even if this is sitting in a SQL database, that information is still, there's a central process which transforms the data from source into a destination. And then you just require some form of cataloging so that people don't create duplicate features, because the risk with something like a SQL data warehouse is that catalog layer isn't something that can necessarily be easily added as a technology stack. It might have to be documentation somewhere. And as we all know, documentation gets outdated. Whereas if you do it with services like Glue, you have the Glue data catalog, which gets updated via crawlers, and that information is always pertinent. It's always current. So I would steer away from doing it in a SQL data warehouse, but you can have a minimal version of that. And maybe that's a good starting point for a company to find out which features can we actually get out of our data. And then once they're confident in the features they can create, they can then look at taking that into production in a real feature store.
Thank you so much for that. There we go. Bradley, please, you have the floor. Please, may I ask a question?
Well, thanks, Simon. Yeah, thanks, guys. It's a great opportunity here. So I don't know if you guys have experience putting this into practice. So I think the biggest problem with data out there is not so much technology is part of it. I mean, it helps it, but I mean, there's a culture around it. I mean, like, how do you stop I think the biggest problem with data, why have your data lakes become data swamps, is that you've got different people putting data in different ways, in different formats. So the main question is have you guys seen how you build a culture around it that doesn't happen? I mean, you can put as much technology in place, but what have you seen that works in practice, and especially in big teams? I mean, we're like a small team here, so the latency is quite small, so we can just say to each other, hey, this would work, this doesn't. So how does it work at an organization that's much bigger?
I think I don't know if you've heard of data ops as a way of work in data, but it's essentially having, sort of like, it relates a lot to the culture, but I think a way of really controlling that is via pull requests. So you have a central repository, you have a way of work that's documented, and you make sure that any change that goes into your feature store goes to pull request. And that pull request has default reviewers. So you can have 3 or 4 people in your project that take ownership of that repository, and at least 2 of them have to approve a pull request. This is especially true in prod. Sometimes in dev, you do want people to be able to play around a bit, because feature engineering is not a straightforward process. Sometimes it's a bit of back and forth. You want to see if the distribution you're getting out actually looks the way that you want it to, or maybe you're playing around with your logic a bit. But in essence, if there's a central repository which features get pushed through and there's some form of governance on that, I think that's the best way of maintaining that. It looks like whoever's behind you is doing some very, very complicated stuff.
He's trolling. He's trying to look like to actually work here. Sorry about that.
With these 3 screens. Oh, actually, no, it's like 4. Yeah.
Yeah, he's trolling us about that. Yeah, so my thing is like, so you got this like feature store here, and I think there's quite a lot of players in that space. So like, if you pull requests, you talk to the dev team, that's fine. But when you start talking to like the analytics team, where the people are a bit more, a bit more in the SQL space, like, pull requests kind of doesn't always fly by. So if you found like that, trying to go to a team that's not, so I feel like a feature store touches like on a point, because you're talking about business analytics and you're going to the ML space. So like, have you seen how it works a bit more on the softer, analytics side?
So just on that also, like one of the biggest issues with any tech thing, as you're probably alluding to, is the orphanage problem, right? Adoption. So getting people on the same page and just knowing, okay, well, this is what we buy into, and we're actually going to do so. But one of the better concepts I heard around this is it's called 051. I'm not sure if you're familiar with that, but it's this idea of, okay, well, first you have nothing, then you're going to have 5 of the same damn thing, because everyone's trying out their different version of it, and then you end up with 1. So part of it is, I suppose, the kind of business ideas are merging towards this more or less. You'd start off with just allowing people the platform to do what they would like to do in whichever way they want to do so, as long as they can motivate it fairly well. And then you'll have 5 versions of the same thing or more. And then at some point you can get all the players into the room and say, okay, we've tried these various versions. We've got, quote, data on how you try to implement this, also from a culture perspective. Let's see what we can all agree on and converge on. It's a kind of like a change management tool. I think that's the best I can do with that for now.
I think another thing we can think of here is that, there's the form of your feature that has to go into production, but then there's also just playing around with stuff, right? So if you're working in a team that has access to a SQL data warehouse, and you just want to, sit there and write SQL queries and, divide this column by that column and then multiply that and see what comes out, and in a notebook, do some visualizations and see, okay, cool, this is how this might work. And then you settle on 10 features that you want to add. Then you go into the feature store proper, and then you go and add that to that feature store. So I think you can get away with a lot of sandboxing, because you don't necessarily want to put everything into production, and you don't necessarily want to use the full compute at your disposal to calculate like a quick logic thing. So I don't know if that kind of speaks to your space. I'm not a DBA, so I don't have that much experience in like SQL data warehouses and stuff. But again, I wouldn't necessarily promote that idea as a final solution. I would say it's maybe a good place to start in a SQL data warehouse, and then once you've got a fair idea of what you want to do, then maybe migrate to something a bit more scalable like Glue. Especially since you don't know how your data might grow over time, and a lot of people end up not being able to run their normal workloads on their SQL data warehouses and having to go to the cloud anyway.
Great. So I hope that has answered your question. I see, Karen, you've got your question up. Please step on the podium.
So just looking at your AWS environment, all your tools here are AWS tools. So I just want to know, using Glue, just as a high level, as an orchestration tool with this environment, Glue will be orchestrating everything within the feature store. Does it work as like an orchestration tool?
It does. It's an option. So yeah, I think that's one thing I left out of those diagrams is the orchestration layer. And that's a very good point. So quite often what you'll find is that you'll have your source systems sitting, let's say, on premise, and that data gets landed into a data lake somewhere. And then we need to have various stages of transformation to get to the final output. And you might find that in your first layer of transformations, you're just doing some basic filtering, like you're dropping certain columns and, dropping certain rows, getting your data into like the right data types. And then in the next layer, you want to do some basic aggregations. And then a layer after that, you want to get your actual features for machine learning. And then maybe a layer beyond that, you want to get your automated feature generation tool to run. And obviously that stuff needs to be orchestrated. So you need to wait for one step to complete before the next one can happen. And so sometimes you'll find that data doesn't land because, IT, everything can go wrong. And so you want to have a fallback mechanism to say that I need to ensure that this data source has landed as well as this one. And if both of them are there, then I can run the next step to create this data source. And this data source and this data source might feed into a next layer, or there might be 3 or 4 that feed into the next layer. And so for the orchestration layer in AWS, you can make use of Glue workflows. But what we've used in the past is AWS step functions to do that. And I mean, there's various ways of doing that. In something like in GCP, you'd use Cloud Composer, which is basically Airflow. But really what you want is a directed acyclic graph. So, a graph that has a certain direction that it's moving in with no loops. And, some form of fallback mechanism so that if part of your pipeline fails, there needs to be some logic, something needs to be fixed. So that could either be some sort of notification that's sent to someone, or there can be automated remediation that can happen to ensure that, sometimes you think there's no data, but it's just that the crawler hasn't run to update the catalog to find that new data. So there's some fallback mechanisms you can work in there, but yeah, either Glue itself or step functions could work for that.
Okay, so you have to explicitly sort of build in those checks whereby some off-the-shelf orchestration tools like Airflow kind of will just show you the DAG and show you there was a failure, whereby here you have to define that if there's a fall off here, you have to sort of catch it. Okay, and you say Glue step functions is something.
So what you can also do is, there can be some decisions in there, right? So if it fails for a certain reason, you can have a Lambda function in there that goes and remediates based on the type of failure. So sometimes it's like, that if the specific failure happens, then it's because of that. And then you can have a different branch be executed instead. But sometimes you'll end up getting an error that you don't know how to catch, like you've never seen this error before. And in that case, you want the whole pipeline to fail, or alternatively, just pause and let someone know that they need to go and investigate it.
So Karen, has he answered your question to the extent that you wanted?
Yes, I don't want to use up all the time.
Yeah, as Brett has said, if there are any more questions, please, we've scheduled for Q2, but we can extend it a bit further. I think one question I want to ask before anyone thinks of additional questions is, you guys have obviously implemented a lot of feature stores in the various companies, but what's the biggest challenge you guys have experienced in implementing it?
I think a lot of it relates to data access. So big organizations have data silos, and quite often there's a lot of IAM permissions that need to be dealt with. And quite often there isn't data when you think there is data, and there's, data is a stream, right? There's a pipeline. And if a piece of your pipe doesn't work, then everything downstream doesn't get data, right? So I think that's one of the big things is that companies, data estates need to be mature, and they need to be able to deliver the data needed for the feature stores. Dom, you've got your hand up.
Yeah, just on that, from some of the environments we've seen thus far in enterprises, the interesting, most say enterprises are, let's say, still relatively new to the whole cloud migration thing. So they tend to be relatively conservative in how they approach governance. So they really lock down and make sure the blast radii are really small, which is great, of course, for safety. And depending on what environment that business is in, they're going to be more concerned about that than less. But on average, it seems that at the moment, because of the maturity of the market, things are still relatively conservative. And so the blast radii are very small, but there's a lot of admin to get data where you need it. So this speaks to what Christian was mentioning now. Sometimes getting access to data is not as easy as, oh, it's just on that S3 bucket, go grab it, or it's in that blob storage. It might be anywhere, and you might even be able to see it, but you can't access it. And you then have to go through a number of hoops, administrative hoops, to get access to that data. So yeah, also to Bradley's earlier point, some of the problems are not so much technological as much as they are, okay, how do I create the business structure around enabling this technology?
Yeah, it's always seems like that, as you said, the adoption, which was I forgot the line that you mentioned, which is quite hilarious, but and quite crude. But yeah, I think it's always the people's problem at the end of the day. If there's no adoption that's happening, then it's really a challenge for one to actually have that innovation in place. Anyone have any additional questions? Michaela, have you got some questions there? I know you're itching to say something.
I see Brad's got a hand that's come back up.
Oh, Brad's got a hand up. Okay, please jump in, Brad. I mean, you're the star of the show today.
Yeah, Brad and Carl.
Thanks. Yeah, yeah, Dom and I go way back. No, so just wondering, have you guys got any experience like with more off-the-shelf implementations of feature stores? One of the big ones is Feast at the moment. My colleague behind here, he was actually left. He's actually contributed to it. But have you guys actually played around with anything like that?
I am aware of it. I haven't looked too much into it, but yeah, do you maybe know of some of the features that it offers out of the box? Because we'd be welcome to hear about your input as well.
And if you know how it compares to SageMaker feature store, because that's the only other one of the box one that I've seen that looks fairly mature. So I don't know if you've played with those.
We're a GCP house, so like no SageMaker is like, it's all Latin to me. So yeah, so the symbols mean nothing. So GCP is a lot more familiar, but I think so. This is all through hearsay. So like the biggest problem we have is what we call like just-in-time joins, whatever. So we've got two different data streams. You know, one's coming at live, and other one's coming, you know, in batches and intermittently. And so it's like to join those up becomes, you know, especially if you're doing like live stream stuff, which I can imagine like Graham and them are doing in an industrial space, it becomes quite challenging just to do that in of itself. So, you know, one of the things that counts is like, you know, as you go down, whatever, it becomes that overhead of trying to get those things joined up, you know, like what happened at this event before and in the future around it, and you want to predict on that. That's much better at doing that. The whole reason why I'm here is that I think it's going to be my homework in the next couple of weeks to like start implementing that. So I'm just wondering if anyone here is, you know,
well, what I can say is whenever I Googled, you know, feature store in Azure, it told me do it in Feast, and it looks like you know, the guys themselves are actually adopting it. So I think, and yeah, it does seem to come up quite a bit. So, I mean, see what it offers and what it doesn't, and, you know, see what additional, you know, functionality you might need to build in. But in GCP, I think you can get away with a lot of the tools that they provide, you know, Dataflow, the data catalog in GCP, and then some custom, you know, if you guys are coding in Python, maybe write some of your own tooling around it. I think it's always nice because, like, depending on the team that you're working in, they might have some specific requirements, and an out-of-the-box tool might not, you know, give you everything you want.
Yeah, so I'm just wondering if,
just on that, what is Feast's main offering? Like, what as a do they give the versioning? Are they big on the versioning? Because I mean, ETL tools are out there. They're plenty.
Yeah.
So what is Feast going for? Like, what is their differentiating factor?
So my biggest thing is like when I've been looking at feature stores, like what is a feature store and what is its core offering? And I think that's a problem. Is like, you know, it's so the problem is like, you know, they're selling this thing as a solution as a feature store, but when you show a feature store, you're showing these group of tools coming together to make up a feature store. So that's what I'm trying to figure out. Is like before getting in there is like, you know, is a feature store more of a concept of like how you set up your data processing, or is it more of a tool that does it? And what I've sort of figured out with Feast is like they've said it's a feature store, but the main thing with them is just the ease of, you know, joining events with, you know, data around it. So if you've got an event, what is the time series data around it? What are the other things associated with it? And it helps with that with the process. But like I said, I haven't implemented it yet. I want to figure it out, but I'm just wondering anyone else.
So for example, I looked into the SageMaker offering a little bit. And the main thing there was, okay, well, you still bring your transformation. So you still have to do, because the transformation, like joining is obviously just one form of transformation. You can have a plethora of things. But then what it offers you is stuff like really, really clever stuff around versioning. Like backdating, for example, right? Like you said,
Yeah.
point in time kind of stuff, or out of time kind of stuff, or versioning my data and versioning the script by which I do the transformation. That it's almost like version control around the data architecture to some degree. And that made a lot of sense, because that's kind of like Christian was saying, and the core of it, it's really just the transformation. On the outside of it is, how do you manage those transformations from a like housekeeping point of view? And so that's why I'd love to have a look at Feast, because I'd like to see what to me, the main kind of, oh, here's a box, here's your feature store offering, would be that versioning stuff, making sure that that's nice and seamless. Like, I don't have to worry about versioning of data or of this script or that pipeline and that kind of stuff.
Yeah, I think, to add to that, what differentiates a feature store from a data warehouse in my mind is the environment around it. It's that, you've got monitoring in place. So you're tracking your variables over time. You're seeing, like, does this mean shift over time? And did something upstream of that change that caused that change? And then you could even have a feedback from your machine learning models to kind of get the values that various features were at that prediction, and then see how that, is there a drift in your predictions over time? So you might find that over time you're predicting more positive responses, and how does that relate to the way that your features changed over time? And is that because COVID happened, or is it because someone in a different data warehouse just changed the way they calculate a feature that you depend on? And then also, like, monitoring the health of your pipelines, and monitoring, where the data is landed, so that orchestration layer that you need, and then, the consumption layer. So it's more like sort of the environment around the data that makes it a feature store for me. Whereas a data warehouse for me is almost just like, there's a SQL script that runs and there's your data. The feature store is more of a comprehensive solution around that, and that can be tailored to your specific needs. Corin or Michaela?
Go ahead, Michaela.
Are you sure? I think you put your hand up first.
No, it's okay. Go for it.
Okay, cool. So my question is, when is a feature store premature in an organization? And when do you know that your organization is ready to implement one?
So I'd say it's premature if you're still just playing. So if you don't have any consistency between the logical transformations that you're doing, and you're just doing high exploitation kind of stuff, then certainly not, because then play away, right? Keep playing and enjoy yourself. And so keeping an eye out of when you might be ready for it. Jot down or keep tabs of what you are trying out, because once you're starting to try out the same or similar things, then you might start thinking about something more that approximates a feature store. But like Christian was saying, when you don't have to then go the full 9 yards and have the back tracing and all of that, you could also just start with, okay, I'm going with a bare minimum, kind of more like an operational database or data warehouse style thing. I'm just making sure that the transformations that I'm doing are centralized. And then after that, if I've maybe then tried them out in analysis or in ML for quite a bit, and I know, okay, cool, I'm static on these, I like them, I'm going to keep them, then definitely build a lightweight feature store.
Yeah, it's an interesting question. It also relates to the question of, when do you get data scientists into your company? A lot of people get data scientists into their company before their data engineering stack is in place. And then their data scientists end up doing data engineering work. So I would almost say that your data engineering platform needs to be mature enough to enable data science. And that, like your basic data estate needs to be in place first. Your data needs to be landing reliably, and you need to have some form of governance in there, and CI/CD and all the bells and whistles. And then you can go for the feature store. Yeah. But also having the feature store also enables the next step of your journey, right? So having the feature store then enables your data scientists to come in much quicker and deliver value with AI. So it's also that aspect of it.
Cool. Thank you.
Cool. Corin?
Cool. So my question, I have 2 questions for you, but I'm sort of also echoing the same as Bradley, like off-the-shelf products on a small team, this type of infrastructure, we wouldn't even know where to start. and how many of these services are required or like just, extras. But basically I want to ask you, your storage, your S3 is just sitting there in the middle, but you might not just store like model outputs or like features. You'd also be storing code, and that along with your data catalog is basically your documentation. So am I correct in saying that S3 storage architecture is probably super important to figure out, like what's going to be feeding out of your process? Because it's not just about storing results, it's about storing processes or possibly packages. If you have any examples, do you know of any open source projects that you guys did, or did you just sort of learn it the hard way? Maybe there's some resources that you've looked at.
Yeah, look, so the S3 thing is really important, because if you're in AWS, Glue actually loads its scripts from S3, so that the scripts that you run are on S3. So the nice thing that S3 does is you can put version control in your S3 bucket, so that people can't just delete data. It stores a version of that data, so that when you delete the data, it's still there, it's just not visible, right? So what can happen is that if I change the way that the logic of my feature is calculated, then I still have a version of that sitting somewhere in my S3 history to say, like, on the 5th of April in 2020, I calculated my feature in the following manner. And that if the auditors come knocking, I can still go back and say that that was the version of the script that ran, and who uploaded that script and why was it changed, kind of thing. So that S3 can be used for that. It's then also like S3 is actually a very interesting way of storing data, because it's not like a hard drive, right? It's actually like a key value store. And so it's almost more like a database than it is a storage device, like a hard drive. But what I was going to say about that is that you've got partitions in S3. So essentially your folders that you create in S3 can be viewed as partitions by your Hive data catalog. And there's some very optimizable things you can do in there. For instance, partition your data by year or month or day, or depending on how much data you've got. And you can then only load the data for that specific partition. Instead of loading all of your data and then filtering afterwards, you can say, I only want data that's after the year 2020. And then I've got 5 folders that I need to read from the beginning. I do that filtering there, instead of reading in all that data, which could be petabytes of data, and then dropping half of it or 3/4 of it and just reading that. So S3 is it's a very big component of this. And some other stuff you can save in there is metadata about your data. So you could actually save like your means and standard deviations for each column in there, and then you can visualize that off S3 as well.
Yeah, so I was going to pick up on that point as well. Yeah, so metadata is also a big thing that we haven't really talked about, but is also very useful about this as it goes on, so that you can save all of that metadata. But I think as far as out of the box stuff goes, the most mature offering I've seen, apart from Feast, which now I'm going to have to check out, is the SageMaker offering. That seemed pretty good. They wrap it all under a nice hood for you, and nice and easily usable. Also, something that I suppose we haven't really talked about all too much is yes, you can either save your script directly in S3, or you could consider to some degree your version control as part of the kind of the feature store ecosystem, and say, well, at this time that we ran that feature, so you save that in the metadata. It had these characteristics. Over time, hopefully you're tracking your metadata. It goes beyond or goes wayward, and you realize, okay, the distributions have changed. Why have they changed? What has changed? Is the data that's changed, or has someone implemented a change to the script or so on? Luckily, version control is great there. Like anything on GitHub, you can go back and roll back and what the hell happened there, who changed, and so on. So one could very much, for now, consider that as part of the kind of feature store ecosystem. But yeah, it'd be interesting to see what some of these kind of closed black box offerings offer in the future, because I think they're going to include a lot of that intrinsically in it, and eventually that's going to make its way to ML ops. So this is kind of like it's all kind of the prequel to what's going to happen in the ML space, I think.
So do you guys know of any open source projects? Probably not. That has
Feast,
this architecture. Feast. Okay, that's all we know
We're
about.
going to have to check that out, yeah.
I know Uber's got a Michelangelo platform that they're prototyping, but I don't know if that's open source or if they're going to white label that or sell it out. But
yeah, I wonder.
Could maybe have a look at that. I know they've got quite a mature feature store offering.
I wonder if
I don't know, I just think
there's a feature store thing in ML Flow. I haven't checked. Sorry, Bradley.
No, so
Jump on,
my
right?
thing is just to take, when I did some reading in the past, just like on what feature store is, my gut feeling at the moment, or like my take of it, I kind of feel like the boundary of what is considered a feature store and what is just considered ML ops and what is just considered data engineering. I don't think that the boundary is being quite defined yet. So that's, I think kind of that's my biggest problem is like when someone says I'm implementing a feature store, where's that boundary box that you're drawing around your implementation? So I think that's kind of the hardest problem with these new things is like, I think a lot of these guys are trying to say like the whole pipeline thing. And I think probably in 5 years time, we could probably tell you what a feature store is. I think now at the moment, we know like more or less what it does, but there's a lot of other stuff that comes with it. I think that's maybe not best to like use a feature store to do it or something calling yourself a feature store, but just to use your own processes around it. So that's just my
it's true. Like a lot of these, like that's the joy of being in an industry that's exponentially expanding, right? The boundaries are constantly shifting. So what we think it is today is not what it is tomorrow. But the interesting thing is that people, like everyone in this room, gets to shape what that becomes over time.
Yeah.
So these kind of forums are awesome for that, because you can just bounce off ideas, and eventually we will get to that 051 thing, right? We're 0, then everyone does their feature store their own way, and eventually people are like, you know what, that was a good implementation. We're going to go with that as best practice, which just, you know, like best practice just somehow becomes the standard eventually.
Yeah, I think it would be great to see that eventually.
Sorry, the other thing I was going to say is that, you know, these buzzwords come up and it's sort of like up to interpretation, right? Like these things just pop up the whole time. But I think that with feature store, it's sort of like, I think it's really useful when you've got like a big organization with multiple data science teams. And a lot of these people are calculating similar things. Like a lot of the machine learning models are going to use the same base data, and they're going to find that that's quite expensive to calculate, right? Like these guys are calculating this heavy transformation and they're using it for this. And these guys are doing exactly the same thing for another machine learning model. And then realize, wait a second, like we could just do that once, right? And it's just there. And how much money can we save? So I think that's also kind of like what makes it a feature store, is that sort of like its reusability for different machine learning models.
Well, I think just from our side is like what we're trying to look at is not so much, you know, we're one data science team or data engineering team or software team, but it's from going from one client to another client. So we kind of want to productize it at the moment. So like what we're finding at the moment is like, because we go to one client, we kind of map that domain. So we know that, you know, 80% of what we can capture is probably going to be the same from one client to the other. So that's what our thinking is with now the feature stores. It should get us that 80%.
But also, correct me if I'm wrong, Brad, you guys are you guys predominantly services based or product based? Probably more product, right?
We're trying to get there. That's the thing.
Okay,
so
so
software
then
as a
that
service. So that's where we're trying to get to at the moment. So yeah.
Yes, perfect. Yeah, no, that makes sense then. Because then you to large degree control what quote feature store becomes for you.
Yeah, exactly. So it's standardized from project. So if we do get more data scientists and whatever, we know this is how the data looks like. It doesn't matter which client you go to, it more or less fits into this template.
Yes. Very cool.
Yeah, I totally agree with that. I mean, I think it really does boil down to reusability. And I mean, this is where we're going to have to end off, ladies and gentlemen. You guys were phenomenal. And this video is recorded and we're going to publish it on our YouTube channel. So please view it if you like to. Follow us on our socials, teraflow.tf. And also, if you want to find out more about this feature store, we actually do have an ebook that these two gentlemen have actually compiled together. Please read that as well. And yeah, keep a lookout for our next AMA sessions. We're hosting this on a monthly basis. But you guys have been awesome, and please enjoy your afternoon further.
Thanks, everyone.
Thanks to the participants and all the questions. That was awesome. Thanks, guys.
Yeah, it's fun. Cheers, guys.
Cheers, guys.